Hi folks, in today's video we are going to be learning about ethers, haloalkanes and reactions with carboxylic acids. So what is a haloalkane? So a haloalkane are substituted alkanes. What that means is that one or more of the hydrogen atoms have been replaced with a halogen atom. They're named very similar to how we name alkanes, whereas if it's a fluorine, the prefix is fluoro, chlorine, chloro, bromo and iodo, just as if you would name methyl, ethyl, propyl, something like that. Here we have a couple of examples. So the first one here, we've been told that it's 1,2-dichloroethane. Now it is 2 carbons in the molecule, so it's going to be ethane, and you can have a look that chlorine is on carbon number 1 and in carbon number 2. Further down we've got a little bit more of a complicated one. We've got 1, 2, so we've got 2 carbons, and this would be a 2, suggesting that it's ethane. Now the reason why we do bromine, then chlorine, then fluorine is because it's alphabetical order. We've got 3 fluorines, 1, 2, 3 on carbon number 1, so the 1,1,1 trifluoroethane. Then we have a chlorine and a bromine on carbon number 2, hence the 2-bromo, 2-chloro. We can have different types of haloalkanes, primary, secondary and tertiary. So a primary is when you just simply have one hydrogen has been substituted. So here for chlorine. A secondary is when you have 2 substituted for a halogen. And then tertiary is when you have at least 3 substituted with a halogen, as I've shown in these examples here. Haloalkanes can undergo 3 different reactions, a couple of different of nucleophilic substitution reactions. So they can form with an alkali to form alcohols. You can also form what's called an alcoholic alkoxide, which is an ether, which is something you'll learn later on in this video. And then last but not least, they can make carboxylic acids with ethanoic cyanide, again, which is going to be further on in this video. So we're going to move on to ethers. Now, ethers are relatively unreactive. And what that means is they're really useful for many things, such as solvents. An ether is something that has an oxygen atom attached to 2 carbon atoms. So if we have a look at this tetrahydrofuran, which we call THF, you can see you've got the oxygen, which is surrounded by the 2 carbons. We have an anesthetic, we've also got a petrol additive, and then at the end we have diethyl ether, which again is a really good solvent. You've got your oxygen surrounded by your 2 carbon atoms. So how do you name an ether? So you have to identify the longest chain, which includes the oxygen. So in this example, it would be here, carbon number 1, 2, 3, 4. Once you've done that, you need to identify the branch of the longest chain with the ether, so this little thing here. And you have to number them and you have to list them alphabetically order. So we've got the 4, hence the butane. Now we know the oxygen or the ether is on carbon number 2. And because there is 2 carbon atoms after it, it's going to be ethoxy. If there was only 1 carbon after it, it would be methoxy. Now we're going to look at some examples of carboxylic acids, how you make them, and a couple of different reactions that they can undergo. So you can make them 2 ways. You can oxidize a primary alcohol or an aldehyde, so depending on how far you want to go. You can also hydrolyze nitrile, an ester or an amide. And typically carboxylic acids undergo 4 reactions. So you can make salts by metals or bases, that's something like NaCNO5. They can undergo condensation reactions with alcohols to produce esters. That's something you learned last year. And you can also make amino groups to form an amide link, something that we introduced last year but maybe didn't go into as much detail. And then this is new, they can also be reduced with lithium aluminium hydride, so your LiAlH4, to form your primary alcohol. So here's a couple of different ways of how you make them. The first one is your oxidation reaction of your primary alcohol to your aldehyde to your carboxylic acid. Then at the end we have our nitrile group, which we can convert into our carboxyl group with your ammonia on the end as well. You can also split up an ester, so we can just break our ester link here to form your carboxylic acid and also your alcohol, so that could be another way of making an alcohol. Same again with your amide linked, so something could potentially be like a protein. You can make your carboxylic acid and also an amine as well. Let's have a look at some of the reactions that they can undergo. So the first one here, we've got our carboxylic acid with our alcohol. We have sulfuric acid as our catalyst, and that means we are making our ester with your ester link. Again, that's something that you learned last year. We have, again, a similar one here, where we have our carboxylic acid and our alcohol, and we've made another ester. So this ester has benzene in it this time, as you can see from your carbon chain, so your C6H5. You can also make an amide, so an amide link here as well, by reacting your carboxylic acid with an amino group, so something like your NH2, to form this bond here as well. And that's a quick introduction to naming haloalkanes, looking at ethers and some reactions that carboxylic acids can undergo.